So, this is the slide where I get to talk about myself. So, I made this project, this password analysis tool, and I think it's different than everything else. I'm really excited to share it with you. I work for a Department of Defense contractor called Partner. We make an Amazon-like page for the Department of Defense. So if you want to buy your paper supplies for Army, Navy, or throw in a grenade launcher or something, then that's what we do. So I've been doing development and security. I love this job because half the time I'm in code, and the other half I get to do security work. A lot of like training, make sure our developers know how to prevent the cross-site scripting, the SQL injection, that kind of stuff. So we got a nice small group. Can I take just a second to learn a little bit about what you want out of this, what kind of interests, what you do? Developers, IT, how would you describe yourself?
I'm a
Sysadmin. Okay. A writer. Excellent. Over here? Sysadmin.
Developer, but kind of jack of all trades.
Excellent. Okay. So, I assume you all hate passwords. Everyone hates passwords, right?
I love passwords.
You love passwords. Excellent. Great. I love passwords. My father-in-law said, "Hey, you're kind of a security guy. You want to tell me about how to make a good password? It's so frustrating." And I was like, "Oh, I could talk for hours on this." So, instead, I pointed him to this website where I have a demo of this project, and he played on it for an hour. I couldn't believe it. He got out his little tablet, and he kept coming back and said, "Hey, look, what do you think of this password?" It turned into a game for him, and it taught him, as he was playing with it, how to make a secure password. And so after that, I thought, I need to do more with this. I need to kind of spread the word, because I think it's a good tool. I think it fills a gap. It fills a need. So, why we think passwords are broken. I don't think anybody really debates.
Not the weakest link.
So this was, 4 years ago? Back to, 4 years ago. 2010. It hasn't gotten any better.
No.
Yeah, there's all kinds of password problems. And everybody, I think the most hated part about passwords are these password policies. You think you come up with this really great password, and it says, no, you didn't insert your special character, you didn't put uppercase, lowercase numbers. So this survey, and there's been several others like it, they came out, they studied a whole bunch of different password policies and the resulting strength that came from those policies. So they analyzed the passwords that people set based on those policies. And nothing had any influence except for the length of the password. So if you required the length of your password to be longer, then that made your password stronger. All the rest of the stuff is garbage. Just throw it away. And security advice from the it's changing. The only thing they're saying now is make it 16 characters.
Greater than 15.
Yeah, greater than 15.
Could you tell that to my bank?
Yeah.
Could you tell that to my bank? They seem to be the worst at password
Exactly.
finding.
Well, they can't let down their guard. Even with 16, character passwords, you can really mess up. So that leads me to my next point. These policies, they don't measure your password strength. They test for compliance with good advice. Sure, you want more randomness in your password. That makes it better, but you can still follow their advice and make some weak passwords. Let's see. So, for example, it's got a number, it's got a special character, it's got a capitalized letter. That's probably pretty easy to figure out. This is a nice long one. This is my favorite because working for the Department of Defense, if you don't have their smart card, we have like some congressmen that want to log in and they don't want to be bothered with a smart card. They have their CAC card. And So we have to have passwords, but the requirement is it has to be 16 characters. It has to be 2 uppercase, 2 lowercase, 2 special characters. This is my favorite password for my test sites. You hold down your hand and go left for Mike, or hold shift down, do it again. Lift your hand up to the numbers and hit 1, 2, 3, 4. Hold shift key down. Totally easy to type, totally easy to remember, and it's really awful. But this will pass any password policy. So there's an example of a really bad password that passes your existing policy. Have any of you not seen this? So this is XKCD demonstrating how password policies have pushed us towards making these really complex passwords that are hard for us to remember, easy for computers to crack. And yet, if we had a more powerful password pattern, I'm going to talk a lot about password patterns. A pattern like this, what do you call this? A passphrase. So correct course battery staple. Easy to remember. But these little squares represent the amount of entropy in that password. So it's a lot stronger of a password than what you see up there, but a lot easier to remember. So I want a tool that encourages this kind of behavior. It doesn't penalize you for these weird password advice things that we're forcing down everyone's throat. So this is the question. Does this make your passwords look fat? No, it doesn't. It makes them look really wimpy. They look anorexic. These are not effective. So if you're in a company that's making these policies, it's ineffective. It's doing more harm than good. It's giving you the illusion of security. So why don't we just measure the password strength? Well, that's not easy. So this is how I do it in this project called OWASP Passfault. First, we identify the patterns. We have the password in clear text when you set it, right? So we rip through it and find as many possible patterns as we can find in it. Then we measure how big those patterns are, how many passwords fit in that pattern. We find the weakest combination of all the patterns. Then we can estimate the time to crack. And this is more important for usability. I mean, this is what I care about, is how many passwords fit in the pattern. But for most people, they don't know the difference between, a trillion passwords and a quintillion passwords. It doesn't have the meaning, it's just a large number. So this estimated time to crack, I think, makes it really simple for everyone. And then we tie that policy to your password policy to the strength that we came up with. So going through this, we got a whole bunch of password patterns. And I have some here that aren't on the list, but we got all kinds of different dictionaries. I just recently reworked the dictionaries. I'll get into that for a bit. So we look for dates, we look for that super uber elite, replace the A with an at, or replace the S with a $sign. So we look for those kind of patterns. We got city names, we got your keyboard sequence, left to right, or even diagonal ones. Inserting special characters. Oh, this is a really cool one, misspelled word. I'm excited about this one. I haven't seen anybody else that does it. It takes a lot more processing, a lot more memory to come up with this. But identifying when you've taken a word and misspelled it is what it looks for. Anything else interesting? And one thing I want to say is the accuracy of this really depends on how many finders we have. Have any of you seen like the GRC password haystacks? Or some of these password evaluators that estimate the time to crack? Those are looking at a brute force random. So take away all of these finders and just leave the random finder, and this would be equivalent to what they've done. That makes sense. So moving on. So we give some research. They have this password haystacks concept, and I really like this because it's easy to understand. Your password is like a haystack with a needle inside it. the hacker wants to figure out, wants to crack your password, he needs to find out where your needle is. And so it depends on how large your haystack is. If it's really large, it'll take too long for him to find it. So this pattern size is a measure of how large this haystack is. I think it's much more accurate, it's more meaningful, and here let's get into this obscurity versus security. You've heard probably some security people saying the difference between obscurity and security. That you want security, you don't want to favor obscurity. So in this system, it favors more of the security side than the obscure. So for example, a backwards word, we'll look up in a dictionary to see if your word is there. If you use a backwards word, that might be more obscure. It's probably not something that a hacker would use first when he's trying to crack your password. But if he knew that you had a backward word, it's going to take him just as much time to find your password as it would if you just used a normal word. That make sense?
Mm-hmm.
So we're going to find lots of different patterns, and some of them might not be what you intended, because we're ripping through this, finding all kinds of misspelled words, repeated characters, and so we play mix and match. We take all the patterns we found and find the weakest combination of them all. And then, once we have that size of the combination of all the patterns, we now know, hey, so this is the game I play. So if I'm a hacker and I know the patterns that you used in your password, how long would it take for me to go through all of those passwords in your pattern? So I've taken like the current metrics from Hashcat. It's a GPU cracker. So it's made to just rip through passwords super fast, use all the different cores inside of your graphical process unit, and it'll crack through passwords super fast. So we've used those metrics to estimate how long it would take for these GPU crackers to crack your password. And then once we know that, we can make a policy. And this policy makes a lot more sense because it's based on something other than good advice. So I want to get to a demo. So if you go to this website, this is where the demo is, HTTPS. I'm piggybacking off of Google's SSL because it does send it across the wire over to the server. And this is probably the biggest question I get is, what do you do with the passwords? Are you analyzing them? Are you publishing them? Do you log them? So instead of going here, I'm just going to show you the URL so you can do it later if you want. Passfault.appspot.com. But instead of doing that, just download the source, go to GitHub, and check out the code. When you get to the code, you'll see these projects. Is that big enough? You know already? So the core is the core library, JSON service. I want this to be accessible to as many developers as possible. It's written in Java, but when we put this out here as a JSON service, it doesn't matter what language you hit it with, because everybody knows and uses JSON. Also got some other projects. An applet, so if you want it to run locally in your browser, you don't want it to go over the wire. It doesn't work for your iPad. But, anything else? So I'm going to go into the JSON service. That is really turned into like if you're wanting to use this, this would be the model, the example application you want to look at as a reference. So we're going to start this up. Jetty run. I've got a new build system, which is just awesome. This is Gradle. I can just tell it to run. And it'll build everything and load it up. And now it's running. Put a local host. So let's increase the font here. I had fun with the logos. I'm not a graphic design guy. but I had fun taking a picture of asphalt and making street signs and stuff, so I hope you enjoyed that. Here's some examples of passwords. Here are 3 passwords that would hash your typical password policy. And below are some passwords that would fail. So let's look at this. This is that keyboard sequence that I was telling you about. So you see it ripped it apart. It found 4 patterns. This is the weakest combination of all the patterns because it probably found others. And here is your time estimate. It says it would take less than a day to crack this password. And it tells you how many passwords are in there. It says this pattern would fit 8 billion passwords, which sounds really big, right? That's why this estimate is important. And if you hover over the patterns, it will give you some more detail, saying, hey, there's only 296 passwords in this horizontal pattern. There's only 296. I counted 3 characters or more. So, just 2 letters next to each other, I didn't count because I figured there would be too many false positives for that. Let's move on. So here's the number, special character, and a word. See, it found random characters. It had special characters in it and numbers in that random bunch. Every time you add more into your random pattern, it gets harder. So if I also threw in uppercase and lowercase, then that pattern would be larger. And this percentile, it tells you how much of that pattern really contributed to the strength of your overall password. So let's go on to here's a completely random word. There's no way this is secure, right? It doesn't have a special character. It doesn't have an uppercase. It doesn't have numbers. How on earth could this be secure? Well, it's completely random. Even though it's lowercase characters, it would take there's 44 sextillion. I have no idea what that is. I just looked up in Wikipedia everything after a trillion. So that's a lot of passwords in that pattern. It'd be hard to crack. Here's a passphrase. It's figured out that there's 2 English words. Figured out that there's a last name. We got that from U.S. Census reports, and it found a Spanish word. And this is pretty good. It gives you 3 quadrillion patterns. It takes 2 days to crack, so that might not fit your risk. If you want credit cards, maybe 2 days isn't enough for you. And it also depends on how you protect your password. So let's go to the next section here, show options. If you are using an older Windows NT LAN manager, it's going to take 2 days to crack this. So if you want to go and boost this up, maybe this is over a password that comes over WPA. You want to see how long it takes for this password to be cracked there. And we bumped it up from 2 days to a century because WPA hashes the password a lot more. If you wanted to go really crazy and do, not crazy, I would recommend bcrypt, SHA-512. OWASP also recommends, you familiar with OWASP? It's an open source umbrella, kind of like Apache, but it's all dedicated towards security. They do top 10 lists, they do cheat lists. If you want to prevent SQL injection, go to their cheat list, they tell you everything. It's a bulleted list of what you need to do. It's a great organization. So if you hash this with SHA-512, we're going to bump it up to a lot more time to crack this. So it depends on not only how you hash it, but also who's hacking. So this estimate is assuming that I'm using just a normal, everyday, a high-end GPU. But this is just assuming one. If you had $5,000 to make a dedicated cracker, it won't take you this long. It'll only take you 75 centuries. But that was quite a jump from 700 centuries to 75. If we spend $50,000 on creating a massive cluster of these GPUs just cranking away at passwords will be able to hack this a lot quicker. So we took it down to 7 centuries. Let's assume that we want, let's say your stuff is really sensitive. You're worried that if governments are going to try to crack your passwords. So assuming they spend $500,000 on cracking your passwords, it'll take them a century for this password. So we went from 100 centuries down to 1 century, depending on who's cracking your password. And this stuff is only getting better each year. They keep coming out with faster GPU processors and more cores inside. So I try to keep this updated on the latest hardware. Any questions on this? Yeah.
What's the cost factor you're using for the bcrypt calculation?
It's interesting because I haven't seen any GPU optimized bcrypt hacking tools out there. And so bcrypt is probably on the high end of the estimation. And I'm not exactly sure if that would be accurate. It might be something about the algorithm that makes it hard to run on these GPU cores. I'm not sure exactly. I'm not sure if I've answered your question either.
Well, so the bcrypt cost factor, I mean, there's a huge difference even just incrementing by 1.
Yeah.
And so let alone ranging from 13 to 31, that's an enormous, I mean, I imagine it would change your century calculation to millennium
Yes.
level calculation.
So I assume you're referring to the workload that you pass to the bcrypt.
Right.
Right.
Cost,
So,
yeah, the cost factor.
so with bcrypt and with scrypt and with the PK, what is it? Password key derivation function. That's the one that OWASP recommends. You can pass in a work factor that would increase. I haven't done that. I've just gone with what the standard bcrypt on Linux is using.
Okay.
I figured I was getting enough into the roots. I didn't want to go too much more. Yeah.
Does your time to crack assume that you can instantly tell whether or not the password was accepted? Because like I've built websites before where we included like a second wait, whether they succeeded or failed.
Yeah.
Right, whether they succeeded or failed to log in, we had a 1-second pause, just to make it so that it makes it time less realistic.
Yeah, excellent. So this is not, this is assuming an offline. It assumes that someone has dumped your database through some SQL injection, and it's an offline attack that can do it as quick as they can actually crash it. I thought about putting on like an online attack. That might be a good idea. Instead of password protection, I can put a pull down for just an online attack, assuming like a 1-second delay.
Well, we actually increased it by a second. We actually had to wait.
Okay.
So
every time it fails, it gets
or
harder.
whether it fails or succeeds. Because if you only do it when it fails, then all they have to do is not wait.
Oh, right.
Right, and say, oh, it didn't come back right away, therefore it must not have been a good password. Right, you're helping them. So you have to pause, even, and you're slowing all your users down by a couple of seconds, or 1 second or whatever, but it's well worth it if you're trying to keep people from.
But that's part of the bcrypt cost, the cost factor in a lot of these too. Is that generally, you crank it up to whatever your current hardware, whatever your acceptable limit is, right? If you figure it's okay for a valid login to take 0.7 seconds, then you crank up the cost to whatever your high-end hardware is going to take about 0.7 seconds.
Yeah. So I wanted to show you the policy. This is how I would envision your security policy looking. You sat over here and say, hey, I'm doing passwords the right way. I'm hashing them a good amount of time. Let's say I assume that I'm not too worried about governments hacking in, but I'm worried about organized crime. So your password policy is basically a slider bar. You set what your risk is. So I imagine as you're doing your risk analysis, you could say, hey, it'll probably take us, if someone, worst case, it takes us 6 months to even figure out that someone hacked in and got our database. At that point, we could do 2 more months maybe, or a month to give the users a chance to change their passwords. So you could, a year policy would make a lot of sense in that kind of a risk. But I guess what I really want to stress is you can't do this now. With your old password policies, you have no idea how strong those passwords are. And so I'm hoping that this will be more of a tool for the admins to say, hey, this is our risk analysis. I don't want any passwords less than this amount of strings. And I don't think there's really any tools out there. There is one other tool. I should change my statement. There is a tool put out by Dropbox about 2 years ago that does a very similar thing. I think I've got some more thorough finders in there that do take up more memory. So if you want this client side analyzed, that the Dropbox would be a good option. Any more questions on like the patterns or the policy? I'm curious. I'd love to ask people questions. You saw a list of the patterns that I looked for. Do you have any passwords that you use that wouldn't match these?
Just have a comment. I found that, and maybe this is something that can be measured, right?
Yeah.
You get to a pain point where people start to write their passwords down.
Yeah.
And it'd be interesting to measure that. Come up and say, here's the ideal password length, because people won't be writing it down on a sticky note by their monitor.
Yeah. And yeah.
So I just went to the one that's live, wherever it is, and pasted in one of my weakest passwords, and it was still like, it was 0% on everything except for random, which was 100%, and it was some scientific notation of centuries, and that was one of my weakest ones.
Okay. Yeah.
Because it was only 20 characters for random.
20 characters full.
Completely 100% random. Full key space.
Okay.
And how do you remember a password like that?
I don't have to. I use the password manager.
Yeah. 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 I love. Let's see. LastPass is what I use.
I use KeepSX and distribute it over LAN with VPC.
Are either of those cost effective? Are they free or
KeepSX is free.
KeepSX?
But there's still some passwords that you just can't.
Right. Like the
You
one
need to
feature-
get in. So.
LastPass for most features is free too.
Yeah.
It's just, there's some advanced features that they
Yeah, I've
have,
ended up
like
paying for
$10
LastPass
a
because
year.
I want it on my phone because that's their.
The mobile client.
Right, the mobile app requires
Yeah.
subscription.
But I love the fact that it's distributed, that I can, get on my parents' computer, log into there, and get my passwords that I need to get into whatever it is, so that I don't have to have my.
Not only is it for pay, but it's, you have to pay for recurring.
Yeah.
Oh, I hate that.
Yeah. Let's see. So this is kind of my marketing slide. So I think it's more accurate. I think it's more informative. I mean, instead of frustrating them, it's turned into a game. Like I told you about my father-in-law, who got really excited, spent an hour changing passwords, and he keeps coming up to me, hey, look at this one. What do you think? This is 10 centuries. Oh, I'm sorry. I wanted to follow up on your question.
Oh,
So I just added some new dictionary words, which I'm really excited about, that aren't live on that site. One of the things it does, you were saying that you had a full random though.
yeah, that's all of my passwords are full random.
Okay.
They're seeded locally, so.
Okay. Yeah, there's nothing more to do on that. But I wanted to mention that these word lists are tiered. Because if you go to like the U.S. Census, if you knew someone used a last name in their password, you wouldn't go through the full list of all the names from the U.S. Census. They're listed by frequency, how much they're used. And so if you got 65% of all the last names, it's only a list of like 4,000 or 5,000. So if you go through that 4,000 or 5,000 names, you're more likely to get a hit than going through the rest, 100,000 names. So we have this tiered database where there's a small set that applies to much more, you're more likely to hit, and then larger sets that are less likely to hit, but more comprehensive. So when you find a word, it's measured by how large that dictionary is. So if you used a word that's used more frequently, say if you like to swear in your password, chances are it will be found a lot quicker because it's a more frequently used word. The words I used, I used English subtitles. There's an open project to get subtitles for movies. So we grabbed 2 years worth of movies, the subtitles from them, found the most frequently occurring words, and those are the top tier of the word dictionary. So I'm excited about those. I'll be pushing those out probably this next week. So how am I doing on time? I'm not
Half hour.
half hour, great. Might be able to get into some code. So I think it's a lot simpler. When things are simpler, it's more likely to get done. And for that, for the admin, I think it's a lot more powerful. I love the idea that you can have a better control of the risk that passwords pose to your organization. This says nothing to client-side hacks where they can find your password. It doesn't improve that situation any. It's only speaking to the length. It doesn't talk about reusing passwords. That's also a concern. So I think best practices around that would be a password manager, and then for the really important passwords that you can't put in your password manager, that this would probably be more helpful.
How often are you supposed to change your passwords?
I don't know. They found that the more frequent you make them change their passwords, the quality of passwords goes down, the strength goes down. So it's kind of a toss-up. I mean, you have that concern of if they're sharing their passwords, using their passwords on multiple sites, and one of those sites gets hacked, you run that risk of them coming in and hacking yours. That's a tough one. I think if you're really concerned about that, I'd add a two-factor authentication. Get some SMS messages or a Google app authenticator. I love that. So did that answer your question?
Yeah.
So the current password advice, or I should say the traditional password advice, I wouldn't say is entirely wrong, because those do contribute, putting in those special characters and numbers, they do contribute to more randomness, but they're not exactly right either. It encourages one type of pattern, and there's lots of other types of patterns, especially ones that are more rememberable. Length is king. 16 characters would be great. 4 random words, I think, is a good pattern to follow. Also, misspelled words. It's really hard to enumerate the ways you can misspell a word, and so that increases a lot of randomness. So if you're a bad speller, good for you. It helps. So,
Question for you.
yeah,
Isn't variety also king?
variety, yeah.
Not repeating letters.
Yes, yeah. One of the things that that Gibson Haystack password thing, that Gibson research, they recommend password pattern. So you have your main password with 10 characters, and then they say pad the rest out to 20 to 30 characters. Not so much. I want to make the pattern finder just for that, because I don't think that as soon as that pattern catches on and people start using it more, then the hackers will catch on and they'll start hacking for it more. Yeah, it increases the search space if you're doing a brute force, but once they catch on to that pattern, I don't think that's a secure.
Also, in hacking passwords, people generally just start at 1 character and they go to 2 characters?
No. I think they would go by what the password policy is. Normally it's 8 characters, so I'd start there.
So we're assuming they have access to the policy.
Yeah.
I was going to say if they have access to the policy, they say, okay, it requires 1 one symbol and one uppercase, then that's all they're going to do.
Yeah.
That just meets the requirements, so it won't yell at me again, and so that reduces the number of things you need to try.
Yep. So if you get a dump of bank's passwords, go to their site, enter in a couple bogus passwords, see what the policy is, and that's going to teach you how to hack your password better. So yeah, I think this introduces much more variability of the options of passwords instead of steering them towards one type of password. And I couldn't really tell you, like personally, the different types of passwords where I don't have them in my password manager. I never am using the same pattern. Like for Facebook, I feel comfortable enough telling you the pattern that I use because I know it's secure. I've got a 6-word passphrase, and not even a phrase. It's just random words. So have at it, you know. And yet for others, you know, just introducing a couple random characters in between words, and I love LastPass. That's your password manager's a good idea. Any questions more on the tool before I kind of go into what's next? Okay, so the core library is Java. I'm getting up to about 10,000 lines of code now. I think it's pretty stable. I've had it running on Google App Engine and haven't had a crash yet, so I think it's safe to use. I think the word lists that I was telling you about make it a lot more accurate. So I think it's close to production ready, if not. I'd like to get more patterns. I certainly can't say that I've got a monopoly on everything people are going to do for their passwords. So if we can get some more patterns, it'll only help. I only have English, really. So I'm targeting the U.S. demographic. I have English and Spanish names and words. So I'd like to get some more languages. So if you speak another language and would like to help out, I do have a Russian keyboard because I wanted to make sure that it was internationalized so that we could get all kinds of different characters. And I would like to refactor it so that as you're typing, it does these calculations rather than at the end you click analyze. So that's another improvement. What I'm really hoping, so I told you that JSON service is kind of the example. That's the de facto thing to follow right now. I'd like to pull out the JavaScript in there so that we can make a simple to use jQuery. I mean, if we get a web developer, all I have to do is say, here's my password field, here's my analysis. They can fill in this is where I want the results to go, and then apply your jQuery plugin. I think that would help adoption. I think people would use it a lot more if it were that simple. And it's close. I mean, it's not too far off. I also got an applet I mentioned. Oh yeah, okay. So I really love to get, for Linux admin or Windows admin, to go to their favorite repository of stuff and say, I want to install Passfault. They click a button, they set the policy, and they're off and running. I don't have the expertise to get into Linux and do that. So I'm hoping that we can get some volunteers, someone that says, hey, I know this stuff, I can help you out there. If you're interested, come chat with me, send me an email. That would be a lot of fun. I would love that. I've never done a whole lot with Windows, so there's no way I'm going to get in there and do that myself. So if you're a Windows expert, that would be great. Also, I want to compile this library down to JavaScript. I think that would also help developers grab this and use it. So Google's Web Toolkit can do that. And I'm excited about that idea. I haven't had the chance to get to it yet. And .NET. Also, there's a plugin for this build system that will compile my stuff down to IKVM, which is the .NET compiled version of the Java class path, so that I could run all of this code in .NET. So if you're interested in testing that out, I'm interested because I don't have the expertise in .NET to be able to see if it works. and there was probably a few tweaks because there's some, loading of the loading of the words from the file system. I'm not sure if that's going to work in a .NET environment coming from the Java. So there might be a few custom .NET things that we might need to do. So if you're into .NET, that'd be great to get some help there. I think that is it. If you're interested in looking at some of the code, I can do that. Or if you have some other questions, I have code here of how you wire this up. This is the JSON service. So here's my elevator pitch. Here is the password form. Here's your input. Here's your analyze button. And the thing to note here is your submit password. I'm including some JavaScript. So if we go over to that. So here, I'll crank up the resolution. Oops. So here's your JavaScript to submit a password. Included in here is both the applet and the JSON service. The applet is the same as the servlet. You send it a password, it'll send back to you JSON. And then you can pass through it, or parse through it, and display the information. So it's just a post. It won't accept anything over a GET, because if you send it over a GET, it's in a URL. It'll be cached in the browser. You don't want your password in there. It'll be cached on the server's logs. You don't want that either. So it just won't accept anything over GET. It'll go over post, and there's your the functions on it when it succeeds. It's pretty simple. Cut and paste that. Put that into your password submit button, and it'll analyze it for you. I wanted to show you the server side. So if we come over to here to this servlet, that is what handles the requests. And so there's not a whole lot of fancy here. You see gets it over a post. I read it straight from the stream because that's here on this get password. I read it straight from the stream because I don't want the framework to be parsing through and loading this into strings. Java has a tendency to keep strings in memory. So I load it into this secure string where I can clear the buffer as soon as I'm done with it. You'll see that in the finally. So regardless of what happens, when I'm done analyzing it, it'll clear that password and it's not stuck in memory. So we grab the password, we stick it in this password analysis. That is the container where it stores all the results. As it's analyzing it, it shoves it into there. So once I put the password in, I call analyze on it, pass in this analysis container object, and then it's multi-threaded, so I call this wait for an analyze. You'll notice when you went out onto the live site, it took a lot longer to analyze your password than it did here locally. And the reason for that isn't the network latency. It's App Engine really kind of constrains what we can do with threads. You have to start up your threads, and they have to die within the scope of a request. So we have different strategies for handling multi-threaded. You can do it sequentially. You can do it the App Engine way, where you start up your threads and then kill them at the end of your request. And that ends up taking almost as much time as you did them sequentially. So if you're doing it yourself and you don't have to host it on App Engine, it'll run a lot quicker, a lot faster. And then we write the JSON out to the response, and you're done. So I think it's pretty simple. It's not too complicated to get it up and going. Any questions?
information is available in that JSON response? Like the crack time or the stack size?
So it will list, I wonder if I can give you an example. So I guess everything that is in this, I have displayed in here, and I've hidden some of it in a mouse over. So when you mouse over each of these patterns, the JSON will contain all of this information. It will contain how much is in that individual pattern. And this is kind of a summary of the collection of all the patterns stuck together. So that's, I wanted to expose this information to the user so they could see what it was that made their password strong or what it was that made it weak. They say, hey, this last name of Davis, here, if I come over here, Davis is a pretty common last name. So there's only, you'd only have to go through 2,000 last names to find Davis. So you can look at this and say, hey, 4%, why am I doing that? That doesn't make any sense. It doesn't help anything. And then that would teach them that, hey, I need to do a little bit more. So hopefully that helps with the self-teaching. I'm way off on answering your question. Did I get your?
Yeah, so follow up to that, then if you were, say, to implement a PAM module to enforce this, so what value or what, from this JSON service, what would you check on to enforce the policy? Time to crack, probably?
I took like maybe 2 hours looking at how to get this in Linux, and I looked up PAM, and I was like, how do I get this information through this interface? And I'm not sure. I don't really answer that.
Yeah, but I mean, the policy, so just time to crack, so you would so your policy would be time to crack root has to be at least such and such time.
Oh, yeah, I see what you're saying. If it were a PAM module, how would you implement the policy?
Right, like what kind of policy would you, how would you define that?
What are the variables you use to determine the policy?
Right.
Yes. Your attack profile, what you assume, who you assume would be attacking you, whether it's government or just script kiddie, and how you hash your passwords. And I'd love if it could look at your existing password hash algorithm and be able to base it off that rather than have you hunt it down and figure it out. That would be really cool.
Sounds like a fun project.
Yeah. Any more questions?
How do we get more of the hashing implementations to be better? Like I complained about the banks earlier. I've red flags every time I see the password policy is no spaces, no special characters, A through Z, and a number. That freaks me out that somebody's storing it in plain text somewhere. That
Just those policies weaken us so much.
Yeah, on that, I'd say generated password. We talked a bit about writing them down, and writing down a generated password. Gosh, if you were stuck on passwords and you couldn't convince anybody in your administration to change, I'd say generate a password, tell them to write it down and put it in their wallet. It converts it into a what you have instead of a what you know. As long as they put it in a wallet and not a sticky tab on their monitor, then that's probably just as good.
Wait. So under what context are we saying, I'm sorry, I came in late, so I probably shouldn't speak. But under what context are we talking about a password taking 2 days to crack? Because when I think of passwords, like you only get so many attempts, that lockout lasts for at least an hour, maybe 24 hours, or maybe you have to reset it from your email. So I generally consider the most secure password is anything over 12 characters, even if it's just regular dictionary words. Probably better if it's dictionary words because then they don't have it available for someone to read.
Yeah.
And then just have the server manage, if somebody's trying 11,000 passwords per second, don't let them in.
Yeah. That's certainly a great strategy. And he would say that he does the same thing, that he limits how many passwords can be checked. I'm assuming with this estimate that you're in a LinkedIn type situation where someone has hacked in, probably through an SQL injection, dumped your database out, gotten all your password hashes, and put it out there for the world to hack. And so it's an offline attack, offline brute force attack is what I'm assuming.
Okay.
And really, that's kind of the worst case scenario. I guess the worst case is if you didn't hash it.
Wasn't, which one was MD5? I didn't even see MD5 on your list. They
Oh, I
said
might not
they
have.
shot one.
Yes. And really, they're pretty equivalent as far as time to hack.
And was this with or without salt?
Salt doesn't change the amount of time it takes. Salt really prevents the rainbow table attack.
Right, okay.
So the time to hash it.
And shared passwords across accounts.
Oh, yes. If you look down the
So
list,
if you happen,
see the
if
same
you happen
hash.
to have gained access to a service that has 2 million accounts, cracking one doesn't necessarily help you crack another.
Well, fun stuff. Thanks for listening. Thanks for coming. I'd love to talk some more if you're interested in helping out. That'd be great. Thanks.